Hey, Mr. Noldy here. Today I'm going to talk to you about, just really quickly, logarithmic graphs. So one thing you have to remember to do a logarithmic graph is remember what an exponential graph looks like. So let's look at just a quick graph here. And I've color coded these, so I'll do the base exponential first, right? The parent function for the exponential graph looks like this. The logarithmic graph is going to look like this. So what do you notice about these? Say this crosses at 1, and we'll say that this one here crosses at 1. So if you understand that inverse functions kind of go across this line here, the y equals x line. So this y equals x is kind of like a mirror. So I have the logarithmic function down here, and I have the exponential function up here. So these two graphs are sort of a mirror image of one another. So the parent function, let's see, get my correct color here. This is y equals b to the x, and that would make this down here be y equals log base b of x. Better be. So when we look at these, we end up saying this one is going to undo this one, because we know one of the characteristics of inverse functions is that their graphs form a kind of mirror image of themselves over the line y equals x. So this is my logarithmic function, this is my exponential function, it's an exponential function. So we'll notice with the exponential function, I have an asymptote at y equals 0. Over here, with the logarithmic function, we have an asymptote at x equals 0. So this will never come over here. So that's one important characteristic to learn, is that if I were to type this into a calculator, and you'll see what I mean, just pick any old number. What's your favorite number? Say -7. We can't take the log of a negative number, because when we look at our graph, you'll notice the domain of this function does not include any negative numbers. So I'm looking at a domain that goes from, 0 to infinity. And we're looking at a range that's coming from down here, negative infinity, and going to positive infinity. So if you remember also about the, if we looked at our domain for this function, it goes from negative infinity to positive infinity, the orange one, and the range is going to go from 0 to positive infinity up here. So if you remember the characteristics of inverse functions, we're just switching the domain and the range around. So that's another property of these. So that's hopefully that's a good primer for you on what these logarithmic functions are. They're just an inverse of a exponential function. The other thing we can do with these logarithmic functions is we can do transformations. We can move them up and down the graph, and we can move them left and right on the graph. So let me show you that just real quick. So consider common log of x plus 1. So one thing we were taught way back in algebra is to start with our parent function. So it looks something like this. When I'm going to add 1, I'm just going to move this graph up and down the y-axis by 1. So by adding this 1, we're just going to have the same graph. Not going to cross, but it's going to be 1 unit higher than the parent function. So if I subtracted 1, it would move down 1. And the other thing that we can end up doing is, let's do one other color. I have log, common log, we'll do again. Only this time, instead of being outside the function, we'll have it be inside the function. And if you remember from when we graphed x squared, y equals x squared, this was in control of moving things left and right. So I would take this and move it just 1 unit to the right. And now everything got shifted to the right. So now I have an asymptote at x equals 1, and this is going to move to the right by 1 unit. I could move it to the left by 1 unit, and sometimes we'll combine them. We'll move it left and right and up and down. And as we get going, we'll add multipliers in here where we can stretch it vertically or shrink it if it's a fraction. And a multiplier in front of the x is going to control shrinking and stretching from left to right. But for the beginning part of it, just remember a logarithmic function undoes an exponential function, and they are mirror images over the y equals x. So if you're getting some value out of this, go ahead and hit the like button, but more importantly, share it with one of your classmates so that they begin to learn what the logarithmic graphs look like. Until next time, this is Mr. Nolde signing out, and don't forget, math's not a spectator sport. If you want to learn math, you have to do math. Until the next time, Mr. Nolde signing out.